Assalamu alaikum dear students. Today we are going to discuss chapter number 5 of book 2 New Lower Secondary Science, and the chapter title is Crystals. Today we are going to discuss about the topic crystals, and today we will discuss about the general properties of crystals, about growing crystals from solutions exceeding their saturation points, and at the last we will discuss how to recognize that the crystallization is a means of obtaining pure substances or removing impurities. So all these topics are to be covered today in this lecture. So first of all, we will move towards what is meant by crystals and what are the properties of crystals. So first of all, I would like to ask from you, have you ever seen common salt or sugar at the close range? If you have looked them close enough, then you will notice that most of the basically sugar and salt are like cubic in shapes and have straight edges with flat, smooth surfaces. So solids, such a type of solids such as salt, sugar, they all are crystals. So the properties, the basic properties of the crystals are, first is they are always solid with fixed regular pattern. Most of them are cubic in shape and have straight edges with flat, smooth surfaces. So if you want to see different types of crystals, then these are present at your home. You can easily analyze salt and sugar crystals. Now come towards the uses of crystals. You have seen most of the crystals. The most common crystal that you have ever seen is silicon. Silicon is used for making electronic circuits. Computer is the best example of the electronic circuit that is made from the silicon. Sapphire is a precious gem. Quartz crystal is used in clocks to keep time. Diamond is used as a cutting tool. So these are the some uses of crystals in our daily life. Now come towards types of crystals. There are different types of crystals depending on different shapes because atoms arranged in different manners. So that is why crystal can be of different types, but their type can only be identified by using different shapes. Now I am going to give you a real life example of the crystal, that is sodium chloride, that is known as common salt. This sodium chloride crystal is cubic in shape. The reason is that because the ions of the sodium and chlorine in the common salt crystal are arranged in a cube pattern, in a cubical pattern. So that is why their arrangement make them cubic in shape and they will form a crystal. There are different methods by which we can easily analyze the crystals, but there are 7 different crystal systems based on the geometrical arrangement of their atoms, and the resultant geometrical structures are shown in the next slide. But before going to next slide, I am going to tell you nowadays different scientists use X-rays to find out about the structures of different crystals. But there are 7 different crystal systems that are based on the geometrical arrangement of atoms and the molecules, and they will result a geometrical structure on the basis of which types of crystals are to be classified. So first of all, The first type that I am going to show you is the cubic system. Now you can see from the diagram that basically cube contains all the sides of equal length. So that is why the cubic system will form with equal lengths of all the sides. Now come towards tetragonal system. So tetragonal system or the tetragonal system crystals result from stretching of a cube lattice along one of its lattice so that the cube becomes a rectangular prism with a square base. Now you can see in the tetragonal system, the base is square while all the sides are of rectangular shape. Okay. Now come towards monoclinical system. Monoclinical systems also contains unequal lengths that are inclined to each other with some angle. And now come towards trigonal system. Trigonal system also contains a system in which tri means three sides. So three sides are of equal length and one side is unequal. So that is why this system of crystal is known as trigonal system. Now come towards rhombic system. So rhombic system form a shape of rhombus. In the same way, hexagonal system make a shape of hexagon. Now come towards the last diagram that I am going to explain you is the triclinic systems. So triclinic system of crystals contains three axes of unequal lengths. You can analyze it from the diagram as well, that triclinic system of crystals contain three axes of unequal lengths that are inclined at non-perpendicular angles relative to each other. So that is why this is known as triclinic system, because three axes are there of unequal lengths. Okay, I think these types are clear to you. Now come towards the topic of crystallization. So crystallization is the process of forming crystal. How crystals can be formed? So we can easily understand this topic because there are several ways by which we can form different types of crystals. Okay, so we will move towards the first formation method of the crystal by which we can obtain different types of crystals. So first method by which we can form crystal is the vapor of a subliming substances cools. So basically when the vapors of the substances that sublimes cool together, so it will appear as a solid crystal. For example, if we will take some iodine crystals and are heated in a evaporating dish, then it will be start to melt very quickly and turns into a violet vapors. And when iodine vapor comes into contact with the cooler part of the evaporating dish, then you will see it will definitely change back into the iodine crystal. So this is the best example to understand how the vapors of the subliming substances cools. Now come towards the second method by which we can obtain or we can form crystal. So second method is a molten substances solidifies on cooling. So substance is in molten state and we have to solidify on cooling it. When a hot molten substance cools down and it solidifies, it starts to convert into the shape of solid, then it turns into the crystal form. So molten substances which solidify slowly produce bigger crystals, and if the solidify time is like fast, then it will produce smaller crystals. So you should keep in your mind that when molten substances solidifies, then if the process is slow, then we can obtain bigger crystals. And if the solidifying time is very fast, then we will obtain smaller crystals like sugar and salt. Now come towards the third process of the formation of crystals. So these all are the methods or the processes by which we can form crystals, and this process is basically crystallization. Now come towards the third method, that is a hot saturated solution is cooled. For example, we can take the example of copper sulfate crystal. How we can obtain the copper sulfate crystals? So first of all, I would like to tell you what is meant by saturated solution. As we have discussed in the chapter number 3, but I am going to explain it you again, that saturated solution is one that contains the maximum amount of dissolved solute in a given volume of solvent at a particular temperature, at a fixed temperature. If temperature is not changing, then the maximum amount that is to be dissolved in the solute in the given volume of the solvent, then we will form a saturated solution. Then a solution is said to have reached its saturation point if it becomes saturated. No more solute can be added into the given amount of the given volume of the solvent. Okay. Basically, copper sulfate crystals can easily be obtained as a hot saturated solution cools, then it will exceed its saturation point. The excess dissolved solute will then appear in the solution as crystals. For example, if we want to make copper sulfate crystals, then we can easily prepare a hot saturated solution of copper sulfate, and then we have to pour some of it onto an evaporating dish, then allow the solution to cool down quickly in the refrigerator and observe the crystal formation. Now take another dish, evaporating dish, pour some of the hot saturated solution onto another evaporating dish. Then allow the solution to cool slowly in your laboratory or whatever where you are performing this experiment, and observe the crystal formation. Then you will observe that the color, size, shape and other physical properties of the crystals formed at different rates of cooling. So you should keep in your mind, as you are cooling the hot saturated solution of copper sulfate in refrigerator, it is quick cooling. It will take less time to solidify it. So that is why basically smaller crystals are obtained, while if you solidify the copper sulfate solution in your lab, then you will observe that it will take because a lot of time to solidify it. So the solidifying process is very slow, so you will obtain bigger crystals. Okay, now come towards the next point, that is the next process by which we can obtain crystals. A saturated solution evaporates. So this is also a method by which we can easily form different types of crystals. So as a saturated solution evaporates, the amount of its solvent decreases, while the amount of its solute remains unchanged, because all the solute is present inside the solvent, maybe in the dissolved form, or maybe some particles are suspended at the bottom of the beaker or whatever in which you have poured it. So this causes the solution to exceed its saturation point. So crystallization begins at this point. Okay. Now come towards the last method that we are going to discuss today. A seed crystal is immersed in a saturated solution. So we can also easily find out how we can form crystal by using this method. For this method, we have to use some operators. So operators required for this practical is fine thread, glass rod, seed crystal, and the saturated solution. So these are the four requirements by which we can easily form different types of crystal. So what should we have to do after acquiring all these operators that is shown on the screen? So you have to take the small piece of the crystal that is basically known as seed crystal. So that is to be tied with the thread and is to be lowered into the saturated solution. Then crystal will be formed on the seed crystal and making it grow. So this method of crystallization is used basically to grow larger crystals. As smaller crystal seed is present there, and as the saturated solution will start to cool down, then more crystal will start or will start to grow bigger. So that is why this process is known as seed crystal is immersed in a saturated solution, because you have poured a seed crystal which is to be grown larger. Okay, so these are the topics that we have to cover today. Today we have discussed about the general properties of the crystals, uses of crystals, types of crystals, and we have also discussed about what is meant by crystallization and what are the methods by which we can obtain different types of crystals. So now it's your turn, dear students. You have to do question number 1, question number 2, question number 3, and question number 4 of chapter number 5, crystal. Review exercise question have to be done by you. You have to complete this assignment as soon as possible, and then you have to send me the pictures of your homework so that I can identify your mistakes. I hope you will basically enjoying the e-learning classes and you are getting the lot of knowledge from the teachers. And stay home, stay safe. Allah Hafiz.